Hello and welcome back. Today we're going to talk about writing and naming formulas for acids and bases, specifically acids. Bases are all pretty much the same. So by the end of today, you'll be able to write acid formulas. If I give you the name, you'll be able to write the name given the formula, and you will be able to describe the three different theories and ways we classify acids and bases. So let's get started. First off, there are two types of acids that we deal with. The first one is called a binary acid, and the second one is called an oxy acid. So these are the two types you'll encounter. Binary acids are acids, the bi means two. So binary acids are acids containing two elements. Typically, it's a hydrogen and then an element that's more electronegative than that. So a hydrogen and a nonmetal. For example, your hydrogen halides, HF, HCl, HBr, and HI, these are all acids. This is hydrofluoric, hydrochloric, hydrobromic, and hydroiodic. When you name them, so steps to name. So for example, HF. Step 1, place hydro at the very beginning. So you start with hydro. So if I have hydro, use the root word of the second element. So hydro, and this is fluorine, so Fl. So fluor is your root. Instead of INE, we're going to change it to IC. So this is going to be hydrofluoric acid. That's HF. That's down here. We also have HCl. So hydro is the first part. The root word is chlor and end in IC. It's hydrochloric, hydrobromic, hydrosulfuric, and hydroiodic. Those are all binary acids. That's a look at how you go about naming them. When we talk about oxy acids, so binary again had two elements. Oxy acids have three typically, three or more. So these are acids containing hydrogen, oxygen, and a third element. So these are, I guess, they're all three elements. That you have hydrogen, oxygen, and some sort of third element, and typically it's a nonmetal. This is where your polyatomic ions come in very handy. If you know your polyatomic ions, naming oxy acids won't be a problem. In order to make something an acid, make your polyatomics an acid, we add H's, hydrogens to the front in order to make it neutral. And then all of your 8 ions become ic acids, and all of your 8 ions become us acids. So we'll look at some examples of this. So for example, let's start with sulfate, because it's here. So sulfate is SO4 with a -2 charge. In order to make, so step 1 is add H's, hydrogens to the front in order to neutralize. So again, hydrogen's got a charge of +1. So because sulfate is -2 and hydrogen is +1, when we cross and drop, we know that we're going to need 2 hydrogens to make it neutral. So this is going to be your formula for sulfate as an acid. And because sulfate ends in 8, it's going to become an ic acid. So instead of hydrogen sulfate here, this is going to be sulfuric acid. And one of the ways I like to remember these is 8 ions. So when I ate something, how was it? It was icky. So if you ate something, it becomes icky for your polyatomic. So if you know your polyatomic names end in 8, the acid is going to end in ic. So sulfate becomes sulfuric, nitrate becomes nitric, phosphate becomes phosphoric, which is a little bit different. Carbonate becomes carbonic. Chlorate is chloric, perchlorate is perchloric, permanganate is permanganic, acetate is acetic, and iodate is iodic. So all your 8 ions become ic acids. Your 8 ions become us acids. So this is one's a little backwards as far as my logic. But if somebody asks you about you and your partner, and you tell them, hey, somebody asked about us, and they say, okay, what'd you tell them? I said, we ate. Maybe not a good thing to say, but it's a way to think about it, that if us is I, then we can go from ions to acids. For example, Nitrite becomes nitrous acid. Sulfite becomes sulfurous acid. Phosphite becomes phosphorus acid. Hypochlorite is hypochlorous. Chlorite is chlorous. And those are your, that's kind of my naming way to remember the names is there. So these are some common names. On the left here is your formula. So if you can look, so for example, CH3COO with a negative sign is acetate. We added an H at the end. So this is one where you don't add the H at the front, it comes at the end. Or you can write it as HC2H3O2. Those are both the same thing. CO3 is carbonate. This is carbonic. Iodic comes from IO3, which is iodate. ClO is hypochlorite, so this is hypochlorous acid. But here's a list showing you all of your not all of them, but a large majority of your polyatomics and the associated acids that they become. I'll give you a chance to work through and name these different acids. If you would pause your computers at this point, pause your screens at this point so I can keep going. I'll give you the names here in a second on the next slide. So as you're moving on, these are your associated these are your names of the acids here, yes. So HI is hydriodic, HCl is hydrochloric, and so on and so forth. So you got names here and you have formulas over here to check yourself. So there's some practice for you.